Thank you. Yeah, this is a new package. It's only been released last December, made public. We've actually been working on it since March. It's not just me. It's going to be also Barrett, who's over there, and Joe Chang. Huge contributions from them to make this possible. So yeah, Rich is my name. Making GT is my game, apparently. And I'm available on Twitter, email, GitHub, all the places. OK. So the GT package, it lets you build display tables with easy-to-use functions. Now, the key was easy. We wanted to make these functions easy to use and fall into a pit of success, really. Table outputs, they can be HTML, LaTeX, that's how I pronounce that, and RTF. Now, the first time I saw RTF, it was a real WTF. So I'm hoping you never have to do that yourself. Generate RTF code. It's actually just hell. So the package is available on GitHub. It's going to be a while until we get it on CRAN. We just really want to get the internals right. So the basic workflow is you got just table data. That's going to be a tibble or a data frame. And you introduce it to GT, and it becomes a GT object. And you can use all the functions inside GT. There's lots to modify the table. What you get in the end is a GT table. And that, again, is HTML, LaTeX, or RTF. That could be done in R Markdown. It could be done in the console, wherever. OK, when we first set out to make this package, we thought, what are some useful features in display tables? What are we bringing to the table, as it were? First thing is kind of obvious, a table header. It's nice to have a title and a subtitle. It's fantastic. It sort of identifies the table, describes it. We had to have that, so we put that in. Row labels. So here's a cool thing. We got cars, and we have these countries where the cars came from. So we basically have like groups of rows. We'll call them row groups. So it allows you to sort of structure your rows, essentially. It's quite nice. And this is probably a bit more familiar. It's column labels, just having column spanners over certain columns. So here we can see performance going over top of a few other columns. A really big thing is data formatting. We want to make it super easy to have your data transformed to any way you want. This is actually a GT table. So as you can see here, the data, of course, doesn't come in this way. You format yourself, and there's easy ways to target different cells and to make the formatting easy. And this was a big one, footnotes. I love footnotes. The idea you can put little notes, you can annotate your table. A real nightmare sometimes when making a table is like getting them in the right order. So GT always puts them in the right order. You don't have to worry what order you specify the footnotes. GT will handle it. So you can see right here, footnotes are kind of small c, so I call them out. It's always going to be left to right, top down in terms of numbering. As you can see the notes at the bottom, they're also in order. So you don't have to worry about order when you're doing footnotes in GT. So in order to make this work really well, we need to define a structure for a table, some sort of like structure that'll solve 90% of your table needs. So we call them table parts. So the most basic table is this. It's very familiar. You got column labels. You got a table body. Table body has cells. It's arranged in columns and rows. Very, very familiar. It's the most basic form of a table. But here's a cool thing, a stub. It's a little known term in table technology. It's essentially like row names, but we can do better than row names like in data frames. We can have a stub that defines, we can have labels for each row. Again, it's not always needed, but it can be useful in certain circumstances, like if rows are representing some sort of thing that you want to call out. And because we can conceivably have groups of rows, it's nice. We can have space there for a row group label that extends out into the table body, which is really quite nice. And a feature of GT is creating summary rows. So if you have summary rows, you can have summary labels. You can identify what are in the summary cells. It could be like an average, a range, what have you. It's nice to describe what that is. Otherwise, you wouldn't really know. So at the top, we have a table header. It's a great place to add a title and a subtitle. The best place, really. And the bottom is the footer area. That's where you throw in the footnotes, as many as you want, and source notes. So it's like a special type of note that just, you can use it for all sorts of things, but typically use it to just, say the source of the data or other things, other little notes that are not really labeled. OK, so the question you might be asking is, do we have the functions to get these display tables made? Yes, we totally do. We have lots of functions. That's why it took so long to get this package out. We were just writing functions like crazy. So the main one is GT. That's how you introduce your table data to GT. So it's great. You have table data, again, tabular data frame, just pipe into GT, and you got that object. And just right there, it looks pretty good. I'll show you some demos. The back half of this talk is like a live coding situation inside RStudio, which is always risky, but I like to live dangerously. So yeah, it may be the case where your table data is huge. It doesn't, it's not really summarized. But luckily, we have tools like tidyr, dplyr, the tidyverse. We can, summarize our data, do cool things to it, reshape it. And then when it's ready, then you bring it to GT for the final touches, as it were. So we have lots of families of functions. I'm going to just introduce you to two families. We have these tab underscore functions. And these are just concerned with adding parts to a table. So they're all targeting a different element. So a tab header is for adding a table header. Spanner is for adding spanner columns. And tab footnote is for adding footnotes, as many as you want. We have a series of formatter functions. They all begin with fmt underscore. And these are great for making the data appear as you want them to appear. It's kind of like in Excel, where you're just selecting a bunch of cells and you're just applying a format. It's the same sort of like idea here. I'll walk you through a few of these just to show you what they do. Formatting numbers is really simple. You use format number. Here's a before and after sort of shot of like the data. So we have this column right here. It's got some data. It's to 3 decimal places. And we can use format number. Just put in the argument decimals equals 1. And yeah, we have it to 1 decimal place and even throws in a comma for you, which you can disable as well. So GT knows about currencies and actually locales too. It's crazy. So it can do all sorts of currencies. You just provide a currency code, which is easy to look up. And we actually have a function that gives you a table of currency codes. And yeah, use currency, format currency. And then that before column becomes a set of currency codes, a set of currencies right here. And the locale here just ensures that the formatting is correct for the locale. Here we're using French in France. So there may be some NAs in your data, and they appear in GT as NAs. Those can be replaced. You just use format missing, choose some replacement text. In the default case, we just use an M dash, and it looks pretty good in a presentation table. But you can choose any sort of like text that you want and target any sort of NAs that are applicable for that text. Okay, there's tons more functions. There's just no time to even mention them here. I gotta move quickly because I really want to get into like the sort of live coding bit, which is going to happen in a sec. Tons of demos I want to show you. The GT package actually comes with 6 example data sets. Country Pops, SEA, GT Cars, SP500, Pizza Place, and Exibble. We're just going to take a look at some simple examples with the Exibble dataset. It's an example table. It's only 8 rows, but it's great for making little small tables. It's just the right size. And we'll use the Pizza Place dataset. So we're going to summarize that a bit because it's a huge dataset of 50,000 rows. Take that, use a bunch of functions on it, get inline HTML. And this is like the secret sauce you need to send an email. We need to have the chunk of HTML to send it out. So let's head on over to RStudio, which I have here. One sec. Okay, so we have 2 packages we need, GT and tidyverse. Can everybody see this, especially in the back? Do I have to pump up the font? No. Pump it up. Okay, I'm going to do that. One sec here. Just bear with me while I go into prefs. What's the usual 18? Does anybody know this? Oh, yeah. Whoa. Okay, hang on. How about tomorrow? People like tomorrow? Yeah? Okay, better than tomorrow night. Okay. Okay, that's visible, right? With almost everybody? Okay, perfect. Okay. So let's have a look at Exibble. It's, again, a data set. So I'm just going to bring this up a little bit. It's just 8 rows. So the features here is that we can use these different columns just to experiment with the API in GT. And importantly, we have these 2 categorical columns, row and group. We can use those to actually create row labels and actually create the groups, like row groups. So let's look at Exibble just piped to GT by itself, how it looks. I mean, not bad. You have the table as it looks there, some row striping. It's reasonable, it's HTML. But here's the cool thing. We can create a stub with row labels and include row groups just by having a few arguments to GT being used. This row name column, we're just passing in column names here. So let's try this, see what we get. There we go. So here's the stub right here, and here's the row groups. So you have group A, group B, and different rows inside those groups. Cool. So now we're going to do a bunch of little function tests here, and we can sort of play around because we're in a live coding environment. So here's a function that's great. Format scientific. So if you want to do some scientific notation, this is nice. All you have to do is supply the column name. We wrap that in bars all the way. So we have places, in this case 3. And so this is going to act on the num column. Let's have a look and see how its scientific notation looks. It's a bit nicer, right? It's got the times 10 to the power of, as you can see here. So it's better than that E notation that you get by default. So we can also format dates in this date column right here. So we have dates as ISO formatted dates right here. They're just as character text, essentially. So here's a really cool thing. We can specify the column date, but we can also specify rows and provide a condition. In this case, we're looking at the column char, and there's a number of different fruits here. So we're just saying for the columns in char, the rows in char that begin with A to D, those are the cells we're going to format right here in date. And we're using date style 6. I'll show you about date styles in a second here. But just see how that works. Yeah, see, there we go. So it's isolated to these cells. So we can target certain cells just by using a combination of columns and rows. So date style 6, how we know that it's actually a good date style? We can use these info functions that give you a table that allow you to sort of see what the different styles are. So there we go. It's info table, and right here, this is number 6. That's what we use, and that's how this date would be formatted. That's great. We got a ton of other info tables too, like info currencies, because who knows all the currency codes. Info time styles, because we might want to format times. And here's a really, really cool one. We can use colors inside GT to color cells with the data color function. It uses palettes, but this is a great way to discover all these palettes. And essentially, this is from the Paletteer package, which is fully supported in here. So tons and tons of colors you can explore just inside GT. Okay, so we can get rid of some columns too if we find that we don't need them, just by using this calls hide function. Okay, so let's try that. Let's get rid of these columns, char, factor, time, date time, and see what that looks like. Okay, now we have a narrower table for sure. It just hid those columns. Because they're hid, they're still usable in these expressions that rely on other columns. So it just means they're not being displayed in the end. But they're still usable for all sorts of things. So we have something called currency. It's not really as currencies right now. We can format it to be currencies. So we can use the format currency function here. So we're going to specify this column, provide the currency code, and this will become currencies in pounds. There we go. Now, here's my favorite thing, adding footnotes, as I said before. Uses the tab footnote function. It's a bit more complicated because you're targeting potentially anywhere in the table to put a footnote. So we have this locations argument, and it takes a number of location helper functions. So we have cells underscore data, cells underscore column labels, title, all sorts of things like that. It just allows you to target where you want to put the footnote, then it attaches it to the end of the text. So in this case, we're using cells data because we want to target some data. And the interface is that we have columns and rows, and it's just like the formatters in this case. We can provide an expression, provide some column name, and so it's going to attach to currencies where the value is less than 20. So just because these are formatted doesn't mean the value is still not there. It's an immutable table inside the actual object, so we can still use the values. So anything less than 20 will get this footnote. These are lower prices at the bottom. It's really small, sorry about that, but it's there. Okay, we're going to add one more footnote to the currency column label itself. We're going to attach it right to the column label. Oftentimes you want to do that, so we'll use cells, column labels, and just provide the column name. And here's a really cool thing. We're providing this second, but it's going to auto-order the footnotes. See, it's become 1 here, and 2 for all these other ones. It changes. It doesn't matter what order we present these footnotes in. It sort of just listens to you and handles that in the end. Great. One thing I neglected is to add a title to the table and a subtitle, so I'm going to do that just by this. Oh yeah, I want to explain that you can throw in Markdown here, just use the MD helper, and then we have this rendered as code, and this will be in bold right there. So let's have a look at that. Great. Yeah, see if I were to not do this, just like get rid of this, maybe just make it italics like that, it will just become italics. Yeah, great. Okay, there's all sorts of other options, sort of stowed away in tab options. It's huge. I don't know if you see the pop-up text. It's truncated because there's like millions of arguments, but basically can change almost all aspects of the table. You can style things. One thing you can change is the footnote glyph. You can, instead, if you tire of like numbers, they can just be letters. So let's try that. Great. Really hard to see because footnotes are tiny, but they became A and B. Because we care, this can be letters or letters like that. So it's that whole pivot success thing. So trying to make it easy. Although this is not easy, you have to know what this is. But I can see this is going to be a vignette one day, describing what these options are. There's lots of them. But essentially, this one allows you to color the background of the column labels blue. Okay. Now let's see what happens there. Okay, turn blue. But the cool thing is the text turn white. It does that for you because it wants to give you the maximum contrast. So it does that with SCSS in the background. If it doesn't do it with that, it does it with some code. So it's trying to give you the best looking table we possibly can. And because we're in a track that cares about R Markdown, here's the whole thing in R Markdown. I'm just going to knit it, and we'll see how it looks. All right, all the chunks have been processed. Here it is in HTML. All the chunks are there, and here's all the tables as HTML. Again, you can do this as PDF. Just change the output type as RTF if you dare, and it's all there. All right, good. Now the final thing, sending an email. I don't know, like getting an email, it could be kind of cool. It's got to be the right type of email. Like if I had an email with a table in it that was useful, that would be kind of cool. So let's load a bunch of packages here that are concerned with that sort of thing. And we're just going to set this up. I'm just going to gloss over this as much as I can because it's not important. It's just getting sort of stuff for the email body itself. So, but I won't gloss over this. So let's look at Pizza Place. It's one of my favorite data sets in this package. 50,000 rows. It's like a year of pizza sales, essentially. Every transaction in that year of a fictional pizza place. So we've got this huge data frame or tibble. If you were to render this in GT, it would be massive. It'd just be a long table. Nobody wants that. So let's do some dplyr. I'm not going to go through the details, but if you just run this code up to here, we'll see that the end table becomes a more manageable 14 rows, which looks great for a GT table. So I'm going to pass that right into GT. Yeah. And there it is. We'll do a few more things, and I'll show you what that looks like. Right here. Great. Fantastic. Very nice. You can put emoji in. That's very fun. And here's the cool thing. As raw HTML, that makes it mailable. So we can just create this email. We'll preview it right inside RStudio. And then I'm going to flip over to my private email. This is I won't show you my embarrassing emails, but I'll show you just this one message. Here it is. It came across, like full fidelity. The emoji is there. The pizza slice is there. All the colors are there. That's an email I want to see. I mean, this is important stuff, pizza sales. Yeah, so that's about it. I'm going to go back to RStudio. To Keynote here, because we're done. And yeah, if you want more information, go to the repo. It's github.com RStudio/GT. This very presentation is in my personal GitHub, if you want to see that and all the data that's there. And otherwise, thanks.
Thank you very much. We've got time for some questions. Do you want to turn around? Let's see how good your catching is. Okay, give us your name and your question, please.
Yeah, my name is Klaus. So this was great. My question is more of a request.
Okay.
I think you'd make a lot of analysts eternally grateful if you could add Excel output.
Yes, I've been asked for various things, Excel, Word, plain text. These are all in the pipeline. For now, we really just want to concentrate on getting parity between the formats I specified, HTML, LaTeX, and RTF. Because right now, certain things are ignored between them, and we want to get sort of like style parity between them. The whole idea is that you write it once, and hopefully, depending on your context, it just works. It may ignore a few things or not, but essentially it should be compatible or portable across the types. But once that's sort of done, in the next few months, we're going to focus on more output types. Even things like SVG, like natively, it's just, we have high hopes for this.
Okay,
Yeah.
and we've got one more question from the back, please.
Hi, my name is Kamal. I was just wondering, can we merge two cells? Is there a functionality in there?
It's there. Yeah, you can do that.
Okay,
There's a
great.
function that I haven't covered.
And just one more. Can I create my own formats, table formats, and apply that to a table?
Yeah, yes to everything.
Awesome.
There's a format function which you can use to make your own function out of. But essentially it's very flexible. I'm going to make a vignette out of that. But essentially what you do is you provide your own code for all the different contexts, which is default, HTML, RTF, and as many as you want. And depending on the context you're in, it'll format like that. You can just use the default as well. But yeah, you can totally do that. It basically just relies on a vector. Some vector processing, essentially.
All right, thank you.